Let me start with a number that is going to reframe everything you think you know about AI engineering careers in 2026. $230,000. That is the estimated total compensation package, base salary, performance bonuses, and equity combined for a senior AI engineer on the AI Foundations team at a company called Employ Incorporated. And I need you to sit with that number for a moment because the story behind it is far more interesting than the number itself. Most people scrolling through job boards right now, looking for senior AI engineering roles, have their eyes fixed on the obvious targets. Google, Meta, OpenAI, Anthropic, maybe a well-funded Series C startup with a flashy name and a product that made the front page of Hacker News last week. And there is nothing wrong with that instinct. Those companies pay extraordinarily well, and the work is genuinely interesting. But here is what the overwhelming majority of AI engineers in the job market right now are missing. Some of the most consequential, highest leverage, and yes, highest paying AI engineering work being done in 2026 is happening inside companies that most people in the tech industry have never even heard of. Employ Incorporated is one of those companies, and by the time we are done with this lecture, you are going to understand exactly why this role might be the single most strategically valuable AI engineering position available in the talent acquisition technology space today. Let me tell you what Employ actually is, because the surface level answer does not come close to capturing the reality. Employ Inc. is the parent company that owns and operates 3 separate applicant tracking system platforms, Jobvite, Lever, and JazzHR. If you have ever applied for a job online, and statistically you almost certainly have, there is a meaningful probability that your application was processed through one of these 3 systems. Together, they serve over 23,000 customers globally. We are talking about companies that range from 10-person startups using JazzHR to process their first handful of hires, all the way up to Fortune 500 enterprises running complex, multi-stage hiring pipelines through Jobvite. Lever sits in the middle, serving the high-growth mid-market companies that have outgrown basic applicant tracking but are not yet ready for full enterprise talent acquisition suites. Now, here is where the compensation picture starts to make sense. When you look at the market data for senior AI engineers in 2026, the numbers tell a fascinating and somewhat counterintuitive story. According to data aggregated from Glassdoor, Levels.fyi, and multiple recruiting intelligence firms, the average base salary for a senior AI engineer in the United States sits around $206,000 as of early 2026. That is up roughly $50,000 from just 2 years ago, representing one of the fastest compensation escalations in the history of software engineering. But averages obscure the real picture. The range is enormous. At the top end, senior AI engineers at companies like Google DeepMind, OpenAI, and Snap are pulling in total compensation packages between $500,000 and $850,000, numbers that include massive equity grants and performance bonuses that dwarf base salary. At the other end, senior AI engineers at smaller companies, non-tech industries, and early-stage startups might see total compensation in the $150,000 to $180,000 range, especially $80,000 range, especially if equity is speculative. Employ sits in an interesting middle zone that most candidates do not think to evaluate carefully. It is a PE-backed, multi-product SaaS company. Its parent investor, K1 Investment Management, is one of the largest private equity firms focused exclusively on enterprise software, with over $13 billion in assets under management. K1 does not invest in moonshots. They invest in companies with existing revenue, existing customers, an existing market position, and then they pour capital into making those companies category leaders. This matters enormously for your compensation analysis, and here's why. When you join a PE-backed portfolio company like Employ, your compensation structure is different from what you would see at a publicly traded tech giant or a venture-backed startup. The base salary for this role, based on market benchmarking against similar PE-backed SaaS companies hiring for senior AI engineering talent, likely falls in the range of $165,000 to $195,000. That is competitive, though not eye-popping on its own. But the total compensation picture gets more interesting when you factor in performance bonuses. PE-backed companies tend to tie significant bonus structures to measurable business outcomes and equity participation. At K1 portfolio companies, equity often comes in the form of profit interest units or management equity plans that vest based on company performance milestones and, ultimately, on the PE firm's exit event. This is where the asymmetrical insight lives. Most candidates evaluating this role will compare the base salary to what Google or Meta would offer and dismiss it. That is a mistake rooted in a fundamental misunderstanding of how private equity compensation works. If K1 successfully executes its thesis, and their track record across over 275 portfolio companies suggests they frequently do, the equity component of this role could generate returns that make the base salary look like a rounding error. The key question is not what does this role pay today, but what does this role pay when K1 exits employ? And what multiple of your equity does that exit generate? Let me put this in concrete terms. K1 typically holds portfolio companies for 5 to 7 years. They acquired the core assets that became employ, starting in 2018 with Jobvite, then added JazzHR and NXT Thing RPO in 2021, and Lever in 2022. If K1 is targeting an exit in the 2026 to 2028 window, which the timing suggests is plausible, then joining this role now puts you in a position to be vested and participating in that exit event. But compensation alone does not explain why this role matters. Let me tell you what makes this position architecturally unique in the AI engineering landscape. Employ is not building AI features. That is the most important sentence in this entire lecture, and I need you to internalize it completely. Employ is building an AI foundation layer, a set of core systems, patterns, evaluation frameworks, and architectural standards that will determine how every AI capability is built, deployed, and governed across 3 separate product platforms, serving over 23,000 customers. The job listing uses a phrase that most applicants will read and immediately forget. This is a systems definition role. Those 3 words contain more information about the actual nature of this work than the rest of the job listing combined. When the listing says systems definition role, what it actually means is this. You will not be shipping features to users. You will be defining the contracts, the guardrails, the state management strategies, the evaluation benchmarks, and the reliability patterns that every other AI feature built at Employ will be required to follow. You are not building a house. You are writing the building code. You are not cooking a meal. You are designing the kitchen. You are creating the infrastructure that makes it possible for other engineers across 3 separate product teams to build AI-powered capabilities that work reliably, safely, and at the scale of millions of candidate interactions per year. This distinction is not just semantic. It has profound implications for what the interview process actually evaluates, what your day-to-day work looks like, and what your career trajectory from this role becomes. And most applicants will miss all of it because they will read the job listing the way they read every other AI engineering listing as a list of technologies to check off. Over the next 9 sections of this lecture, I'm going to dismantle this role component by component. We are going to decode Employ's hidden operating system, how the company actually functions internally, how the 3 product lines interact, and how the AI Foundations team sits within that structure. We are going to map the complete technical architecture, not just the technologies listed in the job posting, but the actual system design challenges you will face when building AI reliability layers for a multi-product platform. We are going to reverse engineer the hiring pipeline, identify the hidden evaluation dimensions that do not appear in any job listing, and prepare you for the specific types of questions and assessments that this team uses to distinguish between candidates who understand AI features and candidates who understand AI systems. By the end of this lecture, you will know more about this role, this company, and this opportunity than 95% of the candidates who apply. And that knowledge differential, that gap between what you know and what everyone else assumes, is where the real competitive advantage lives. That is where the $230,000 lives. Let us begin. To understand why this AI engineering role matters, and more importantly, to understand what the interview process is actually testing for, you need to understand how Employ Inc. actually works. Not the version you will find on their website, not the polished narrative in the press releases. The structural reality of how a private, equity-assembled collection of 3 separate technology companies tries to function as a unified entity while simultaneously building an AI layer across all of them. Employ's origin story is a private equity roll-up, and if you do not understand what that means in practical terms, you will fundamentally misunderstand the engineering environment you are walking into, and you will fail the interview for reasons you will never be able to identify. Here is how Employ came to exist. K1 Investment Management, the PE firm behind Employ, operates on a very specific thesis. They look for enterprise software companies that have strong market positions in fragmented verticals, acquire them, combine them under a single corporate umbrella, and then use operational leverage, shared infrastructure, cross-selling, consolidated R&D, unified go-to-market strategies, to create a company that is worth significantly more than the sum of its parts. It is the private equity playbook applied to B2B software, and K1 has done it more than 275 times. The Employ roll-up started with Jobvite. Jobvite was founded in 2006 and had established itself as a well-known enterprise ATS platform with particular strength in recruitment marketing, social recruiting, and employee referral systems. K1 made a $200 million investment in Jobvite that funded a series of tuck-in acquisitions: Telemetry, a recruitment marketing firm; Canvas, a text-based interviewing platform; Rollpoint, an employee referral system; and Talentegy, a talent analytics platform. Each acquisition added a capability layer to the Jobvite ecosystem. Then in 2021, K1 added JazzHR, which had built a strong position in the small to medium business segment, and NXT Thing RPO, a recruitment process outsourcing firm. In 2022, the biggest acquisition landed, Lever, a modern applicant tracking system and CRM hybrid that had carved out significant market share in the high-growth mid-market segment. All of these entities were combined under the Employ Inc. corporate umbrella. And this is where the story gets architecturally interesting for anyone considering an engineering role. Here is the fundamental challenge that defines Employ's engineering environment, and that the AI Foundations team exists specifically to solve. Jobvite, Lever, and JazzHR were not built together. They were not built on the same technology stack. They do not share a database architecture. They do not share an API layer. They do not share a data model. They are three separate products built by three separate engineering teams over the course of nearly 2 decades of independent development that are now expected to operate as a unified platform ecosystem. This is the challenge that most applicants for this role will never grasp, and it is the challenge that every single question in the interview process is designed to probe your ability to navigate. When the job listing says you will define contracts, state management strategies, and guardrails for AI-driven workflows, what it is actually saying is you need to build an AI abstraction layer that can operate across 3 fundamentally different product architectures simultaneously. The AI Foundations team is not building AI for one product. They are building AI infrastructure that must work reliably across 3 products with different data models, different API paradigms, and different customer expectations. Let me walk you through the organizational structure so you understand exactly where you sit. Employ operates with a shared corporate function layer, engineering leadership, product strategy, HR, finance, that sits above the 3 product lines. Below that corporate layer, each product line, Jobvite, Lever, JazzHR, maintains its own engineering team, its own product managers, and its own customer base. The AI Foundations team sits at the corporate infrastructure level, meaning it is a horizontal team that serves all 3 verticals. This organizational positioning is unusual and carries specific implications that you need to understand for the interview. As a member of the AI Foundations team, you are not embedded in any single product team. You are building systems that every product team will use. This means your stakeholders are not product managers asking for features. Your stakeholders are other engineering teams asking for reliable, well-documented, production-grade AI infrastructure that they can build on top of. The job listing describes this as set direction and elevate the organization, and it means exactly that. You are establishing the architectural patterns and standards that other teams adopt. This horizontal positioning also means that the politics of the role are different from what most engineers are used to. You are in a service role relative to the product teams, but you also have architectural authority. When you define the schema enforcement strategy or the evaluation framework for AI-generated outputs, the product teams are expected to follow that standard. This creates a unique dynamic where you need both deep technical capability and the communication skills to build buy-in across teams that may have different priorities, different technical cultures, and different opinions about how AI should work in their products. Now, let me describe the business model because this directly affects what the AI Foundations team is building and why. Employ makes money through SaaS subscriptions. Jobvite charges enterprise customers on annual contracts that typically run in the tens of thousands to hundreds of thousands of dollars per year. Lever operates on a similar model at a lower price point for mid-market companies. JazzHR is the volume play. Lower price points, higher customer count, faster sales cycles. The combined revenue across all 3 platforms plus NXT Thing RPO services creates a diversified revenue base that K1 can point to when it comes time to exit. The AI Companions initiative, Employ's branded AI product layer, is a strategic bet that will significantly affect the company's valuation at exit. If Employ can demonstrate that its AI capabilities meaningfully differentiate its ATS platforms from competitors like Greenhouse, ICIMs, Smart Recruiters, and Workday Recruiting, the company's multiple at exit goes up. If the AI layer is perceived as superficial or unreliable, it becomes a marketing bullet point rather than a value driver. This is why the AI Foundations team exists as a distinct, high-ownership entity within Employ rather than being distributed across product teams. K1 and Employ's engineering leadership recognize that letting each product team independently implement AI features would result in inconsistent quality, redundant work, and, sometimes most critically, governance gaps that could expose the company to regulatory and reputational risk. The AI Companions need to meet a specific reliability and governance standard because Employ's customers are making hiring decisions based on AI recommendations. If those recommendations are biased, unreliable, or unexplainable, the legal and reputational consequences cascade not just to Employ, but to every one of their 23,000 customers. This brings us to the IBM Watsonix partnership, which is arguably the most important piece of context for understanding this role that almost no applicant will have researched. In 2025, Employ announced a formal partnership with IBM watsonx to provide the governance layer for their AI companion portfolio. What this means in practice is that Employ's AI systems are not operating in a governance vacuum. They are operating under a governance framework, watsonx.governance, that provides monitoring, bias detection, explainability, and audit capabilities. For the AI Foundations team, this means you are not just building AI systems that work. You are building AI systems that work within a specific governance infrastructure that has its own constraints, its own APIs, and its own requirements. This is the hidden evaluation dimension that I mentioned at the top of this lecture. Most AI engineering candidates, when they prepare for interviews, prepare to demonstrate that they can build systems that are fast, accurate, and scalable. All of those things matter. But at Employ, the AI Foundations team is also evaluated on your understanding of responsible AI governance, your ability to build systems that are auditable and explainable, and your capacity to design AI architectures that integrate with an external governance layer without sacrificing performance or developer experience. The interview will not ask you to recite IBM watsonx documentation, but it will probe whether you understand why governance matters in an AI system that makes hiring recommendations, how you would design an evaluation framework that captures not just accuracy but fairness, and how you think about the trade-off between model flexibility and governance compliance. Let me give you one more structural insight about how Employ operates that will differentiate you from other candidates. The Glassdoor reviews for Employ, and I want to be direct with you about this, paint a complicated picture. The company has a 2.8 out of 5 rating, with recurring themes around executive turnover, strategic clarity, and the challenges of integrating 3 separate product cultures under a single corporate umbrella. Some reviews describe strong individual contributor teams operating in a difficult corporate environment. Others describe engineering leadership that is still finding its footing after the rapid acquisition phase. I'm telling you this not to discourage you from applying, but because understanding the organizational reality is a strategic advantage in the interview. If you walk into the interview with a naive assumption that Employ is a smoothly running enterprise, you will give answers that sound disconnected from the actual challenges the team faces. If instead, you demonstrate awareness that building AI infrastructure across 3 heterogeneous products within a PE-backed organization is inherently complex, and that you have thought carefully about how to navigate that complexity, you will stand out from every other candidate who prepared by studying LangChain documentation. The AI Foundations team was created specifically to bring order to complexity. Your interview answers should reflect that you understand what kind of complexity you are bringing order to. Now, we are going to go deep into the technical reality of this role, not the technologies listed in the job posting. Anyone can read that. We are going to examine the actual system design challenges that define what the AI Foundations team builds every day, why those challenges are significantly more complex than what the listing suggests, and which specific technical skills separate the candidates who get offers from the candidates who do not. Let me start by deconstructing the technology stack as it appears in the job listing, and then I am going to show you the layers of complexity that live beneath each item. The listing mentions Python, including Asyncio, decorators, and the modern Python ecosystem. It mentions TypeScript and Node for integration and application layer logic. On the AI stack side, it calls out orchestration frameworks like LangChain and LangGraph, or custom agent loops. It mentions retrieval, augmented generation systems, hybrid search with re-ranking and chunking strategies, and vector databases including Pinecone, pgvector, and Weaviate. For infrastructure, it calls out advanced SQL, Docker, Kubernetes, and experience running isolated environments for code execution. That looks like a standard senior AI engineering tech stack listing in 2026. But the actual work, the systems definition work that this role entails, lives in the gaps between those bullet points. Let me walk you through the real architecture. The first and most fundamental technical challenge is what I'm going to call the multi-product abstraction problem. Employ operates 3 ATS platforms. Each platform has its own data model for representing candidates, jobs, applications, interview stages, evaluations, and hiring outcomes. When the AI Foundations team builds a RAG pipeline for candidate matching, for example, that pipeline cannot be designed to work with just one data model. It needs to work with 3 different data models, or it needs to work with an abstraction layer that normalizes the differences between them. This is a system design problem that most AI engineering candidates have never encountered, and it changes everything about how you think about retrieval, indexing, and embedding strategies. In a single product environment, you build your vector embeddings from a unified document schema, and your retrieval pipeline queries a single index. At Employ, you are potentially dealing with 3 different candidate document formats, 3 different job specification structures, and 3 different sets of metadata fields that affect how relevance is calculated. The The chunking strategy that works beautifully for Lever's modern data model might produce terrible results when applied to Jobvite's legacy data structures, and the re-ranking model that performs well on JazzHR's simpler document format might over-index on certain features when applied to Lever's richer candidate profiles. This multi-product abstraction challenge affects every layer of the AI stack. When you are building agents that interact with the platform, and the job listing specifically mentions agents and orchestration layers, those agents need to understand which product they're operating within. An agent that automates candidate outreach in Jobvite interacts with a different API surface than an agent performing the same function in Lever. The contracts, the state management, the error handling, and the fallback strategies all vary by product context. Now let me talk about the orchestration layer, because this is where the role gets genuinely interesting from a systems design perspective. The job listing mentions LangChain and LangGraph as orchestration frameworks. These are widely used tools, and if you have built LLM-powered applications in the last 2 years, you have probably worked with at least one of them. But the listing also says, or custom agent loops, and that small phrase reveals something important about the team's technical philosophy. The AI Foundations team is not religiously committed to any single orchestration framework. They are evaluating and potentially building custom orchestration infrastructure that meets their specific reliability and governance requirements. This makes sense when you think about the IBM watsonx governance integration. LangChain and LangGraph are excellent tools for prototyping and building AI applications quickly. But when you are operating under a governance framework that requires structured logging, telemetry, tracing, and performance monitoring, as the job listing explicitly states, you may need finer-grained control over the orchestration layer than an off-the-shelf framework provides. You may need to build custom agent loops that integrate governance checkpoints directly into the execution flow, rather than bolting governance on as an afterthought. Let me paint a more concrete picture. Imagine you are building an AI screening companion, which is one of the products Employ has already announced. This companion continuously matches candidates to open roles, identifies talent at risk of disengagement, and automatically provides personalized feedback to rejected candidates. Think about the orchestration requirements for that system. You have an agent that needs to process a continuous stream of candidate data from multiple sources. For each candidate, the agent needs to retrieve relevant job listings, compute matching scores using an embedding-based similarity system, apply business rules specific to the customer's configuration, check for potential bias in the matching output using the watsonx governance layer, and then generate personalized communication that is appropriate for the candidate's status in the pipeline. Each of those steps has its own failure mode. The retrieval might time out. The embedding service might return degraded results under load. The bias check might flag an output that requires human review. The communication generation might produce text that violates the customer's brand guidelines. The orchestration layer needs to handle all of these failure modes gracefully, with retries, fallbacks, and failure mode containment, which, not coincidentally, is exactly what the job listing calls out under engineer reliability at scale. Let me now address the structured data enforcement dimension, because this is an area where the AI Foundations team's work is genuinely cutting edge relative to the broader AI engineering industry. The listing specifically mentions experience enforcing structured outputs using schema validation tools such as Pydantic, Zod, or JSON schema. This is not a nice to have. This is a core architectural requirement. When an LLM generates output that will be consumed by downstream systems, and in the ATS context, that output might be a candidate matching score, a set of interview questions, a rejection message, or a skill assessment, that output must conform to a strict schema. It cannot be free-form text that a downstream system has to parse and hope for the best. The structured data enforcement layer is where the AI Foundations team defines the boundary between probabilistic AI outputs and deterministic system behavior. This is what the job listing means when it says you will transform probabilistic model outputs into reliable, production-grade product capabilities. The LLM produces a probabilistic output. The schema enforcement layer validates that output against a defined schema, handles cases where the output does not conform, and produces a structured data object that the rest of the system can rely on. Building this layer well requires deep understanding of several interconnected technical domains. You need to understand how different LLMs produce structured output. Some models respond well to JSON mode instructions, others need more aggressive prompting strategies, and the quality of structured output varies significantly across model providers and model sizes. You need to understand how to design schemas that are both strict enough to ensure downstream reliability and flexible enough to accommodate the inherent variability in AI-generated content. You need to understand how to implement retry and correction strategies when the initial output fails validation. Do you retry with a modified prompt? Do you attempt automated correction of the malformed output? Do you fall back to a simpler model that is more reliable at producing structured output? The Pydantic mentioned in the job listing is particularly significant. Pydantic is not just a validation library. In the context of modern AI engineering, it has become the de facto standard for defining the contracts between AI components. When the job listing says you will define contracts and API contracts that AI systems interact with, Pydantic is likely the primary tool being used to express those contracts. If you have not spent significant time working with Pydantic's model configuration, custom validators, and integration with LLM output parsing, that is a gap you need to close before the interview. Let me now talk about the event-driven architecture dimension, because this reveals the engineering maturity that employee expects from candidates. The listing calls out experience designing decoupled systems using queues such as Kafka, SQS, or Bull MQ. In the context of the AI Foundations team, this requirement exists because AI operations in a production ATS cannot block user-facing workflows. When a recruiter is screening candidates, the AI matching system needs to operate asynchronously. When the AI screening companion is generating feedback for rejected candidates, that generation cannot hold up the rejection workflow itself. The entire AI layer needs to be event-driven and asynchronous, processing work in the background and delivering results through a message queue that the product teams consume at their own pace. This has profound implications for state management. The job listing mentions experience persisting state across sessions, managing context windows efficiently, and handling concurrency and race conditions when multiple agents interact with shared data. In the multi-product, event-driven architecture of Employee's AI layer, these are not theoretical concerns. They are daily engineering challenges. Consider this scenario. 2 different AI agents, one performing candidate matching and another performing engagement risk assessment, are both operating on the same candidate record in a lever instance. Both agents need to read the candidate's current state, perform their respective operations, and write their results back. If they do this concurrently without coordination, you get a classic race condition where one agent's output overwrites the others. The state management strategy needs to handle this through some combination of optimistic concurrency control, event sourcing, or agent coordination protocols. This is the kind of problem that the interview process will test you on, not by asking you to recite the theory of concurrency control, but by presenting you with a system design scenario and evaluating whether your proposed architecture naturally handles these kinds of multi-agent state coordination challenges. The vector database layer deserves specific attention as well. The listing mentions Pinecone, pgvector, and Weaviate, which covers 3 different approaches to vector storage. Pinecone is a managed vector database optimized for simplicity and speed. pgvector is an extension for PostgreSQL that allows you to store and query vector embeddings alongside your relational data. Weaviate is an open-source vector database with built-in hybrid search capabilities. The fact that the listing mentions all 3 suggests that the team is either evaluating which solution to standardize on, or, more likely, using different vector stores for different use cases. pgvector makes sense when you want to keep vector embeddings close to your relational data, which is useful when your retrieval queries need to combine semantic similarity with traditional SQL filters. Pinecone makes sense for high throughput, low latency similarity search, where you are willing to maintain a separate data store. Weaviate makes sense when you need hybrid search that combines vector similarity with keyword-based BM25 scoring in a single query. For the AI Foundations team, the choice of vector store is an architectural decision that affects every product team downstream. If you standardize on pgvector, you get the benefit of a unified data layer, but you may sacrifice query performance at scale. If you go with Pinecone, you get performance, but you introduce data synchronization challenges between your primary database and your vector store. If you choose Weaviate, you get hybrid search out of the box, but you take on the operational complexity of managing another infrastructure component. The interview will likely explore how you think about this kind of technology selection decision. Not which vector database is best, that is a meaningless question without context, but how you evaluate trade-offs across performance, operational complexity, data consistency, and governance requirements. Your ability to articulate a clear evaluation framework for this kind of decision is more valuable than deep expertise in any single tool. Let me close this section with the infrastructure layer. Docker and Kubernetes are listed as requirements, along with experience running isolated environments for code execution. That last phrase is interesting and somewhat unusual in an AI engineering listing. Isolated environments for code execution suggests that the AI Foundations team is building systems where AI-generated code or AI-orchestrated operations need to run in sandboxed environments, containers that are spun up, execute a task, and are torn down without affecting the host system or other running processes. This is relevant because one of the emerging patterns in agentic AI is allowing agents to execute code as part of their workflow. For example, an agent that generates a data analysis query, executes it against a database, and uses the results to inform its next action. Running that kind of code execution safely in a production environment requires containerization, resource limits, network isolation, and careful security boundaries. If you have experience with this pattern, building sandboxed execution environments for AI agents, that is a significant differentiator for this role. The technical architecture of this role is deep, multi-layered, and genuinely challenging. It is not about knowing any single tool or framework. It is about understanding how to design systems that are reliable, governable, and adaptable across a heterogeneous product landscape. That is what the interview tests for. That is what the AI Foundations team needs, and that is what separates the $230,000 total compensation from the $150,000 alternative. Here's the deeply ironic thing about applying for a senior AI engineering role at the company that builds the software other companies use to process applications. Your resume is going to be processed through one of Employ's own systems. You are being evaluated by the machinery you are applying to build. Understanding how that machinery works, and more importantly, understanding what happens at each stage that the machinery cannot see, is the difference between being one of the hundreds of applicants this listing will attract and being one of the 5 to 8 candidates who make it to the final interview round. Let me walk you through the full pipeline, stage by stage, with specific attention to what is being evaluated at each gate and why most candidates are eliminated long before they ever speak to a human. Stage 1 is the application submission itself. For a role at Employ, your application almost certainly flows through either Lever or Jobvite. Employ uses its own products internally, which is both a matter of principle and a practical QA strategy. When you submit your resume, it enters the ATS and goes through automated parsing. The system extracts your contact information, work history, education, skills, and any other structured data it can identify from your resume format. Here is what most candidates do not realize. The quality of the data extraction varies dramatically based on how your resume is formatted. If your resume uses complex tables, multi-column layouts, or embedded images for section headers, the parser may struggle to extract clean, structured data. This means your carefully designed resume, the one with the beautiful 2-column layout and the custom typography, might actually produce worse data quality in the ATS than a simple, clean, single-column format. This is especially true for AI engineering roles where your technical skills section is critical for automated matching. The parsed resume data is then used for initial matching against the job requirements. This is where Employ's AI screening companion becomes relevant. The system evaluates your profile against the defined requirements for the role and generates a matching score. Based on that score and any other filtering criteria set by the recruiter, your application is either advanced to recruiter review or deprioritized in the queue. For this specific role, the matching criteria almost certainly weight heavily toward experience with the specific technologies listed in the posting: Python, LLM orchestration frameworks, RAG systems, vector databases, event-driven architecture, and structured output enforcement. But here is the asymmetrical insight. The matching algorithm does not just look for keyword presence. It evaluates context. Mentioning LangChain on your resume is worth significantly less than describing a specific system you built using LangChain to solve a production-grade orchestration challenge. The AI screening companion is likely trained to distinguish between keyword-stuffed resumes and resumes that demonstrate genuine depth of experience. Stage 2 is the recruiter screen. If your application passes the automated filtering, it lands on a recruiter's desk. At a PE-backed company like Employ, the recruiter screen is typically a 20 to 30-minute phone call focused on 3 things: confirming the facts on your resume, assessing your communication style, and evaluating your salary expectations against the role's compensation band. The compensation conversation at this stage is critical, and I want to give you a specific tactical recommendation. Most candidates, when asked about compensation expectations, either deflect the question or name a number based on their current salary plus a percentage increase. For this role, you should be prepared to discuss compensation in terms of total compensation, not just base salary. Demonstrate that you understand how PE-backed equity works, that you know K1's investment thesis, and that you are evaluating the role based on the full compensation picture, including the equity trajectory. This immediately signals to the recruiter that you are a sophisticated candidate who understands the business context, not just the engineering challenge. Stage 3 is the hiring manager screen. For the AI Foundations team, the hiring manager is likely the team's engineering lead or the VP of engineering overseeing AI initiatives. This conversation is typically 45 minutes to an hour and goes deeper than the recruiter screen in 2 dimensions. First, the hiring manager evaluates your systems thinking. They want to understand how you approach complex technical problems at the architectural level. They are not looking for you to solve a coding problem on a whiteboard. They are looking for evidence that you can decompose a high-level business outcome, like build a reliable candidate matching system that works across 3 products, into an executable technical system with clear component boundaries, well-defined interfaces, and realistic implementation timelines. Second, the hiring manager evaluates your ownership mentality. The job listing uses phrases like high ownership and high autonomy to describe the team culture. In the hiring manager screen, this translates to questions about times you defined a technical direction without being told exactly what to build, times you identified a problem before anyone asked you to solve it, and times you influenced technical decisions across teams that you did not directly manage. Stage 4 is the technical assessment. Based on patterns at similar PE-backed SaaS companies hiring for senior AI engineering roles, the technical assessment for this role likely takes one of 3 forms, and I'm going to prepare you for all 3. Form 1, a system design session. You're given a problem that mirrors the actual work of the AI Foundations team, something like design a RAG pipeline that serves candidate matching across multiple product instances with different data models, and you have 60 to 90 minutes to work through the architecture on a whiteboard or shared document. The evaluators are assessing your ability to identify components, define interfaces, handle failure modes, and make explicit trade-offs. Form 2, a take-home project. You're given a more open-ended challenge, something like build a simple agent orchestration system that processes a queue of tasks, validates structured outputs, and handles retries for failed operations. And you have 3 to 5 days to submit a working implementation. The evaluators assess code quality, architectural decisions, error handling, testing strategy, and documentation. Form 3, a live coding session focused not on algorithms, but on systems. You might be asked to implement a schema validation layer using Pydantic, or to write an async Python function that processes a queue of LLM calls with retry logic and structured output enforcement. The evaluators are looking at how you think in code, not whether you can solve a LeetCode code problem. Regardless of the format, there is a hidden evaluation dimension at every stage of the technical assessment. The AI Foundations team is not just evaluating whether you can build AI systems. They are evaluating whether you can build AI systems that other engineers can use. This means your solution needs to be well documented, well structured, and designed with developer experience in mind. The best candidate is not the one who builds the cleverest solution. It is the one who builds a solution that the next engineer can understand, extend, and maintain. Stage 5 is the team interview panel. If you pass the technical assessment, you meet with multiple members of the AI Foundations team and potentially cross-functional stakeholders from the product teams. This round is evaluating cultural fit, collaboration style, and communication capability. Can you explain complex technical decisions to engineers who are not AI specialists? Can you listen to product requirements and translate them into technical specifications without losing important context? Can you disagree constructively when your architectural recommendations conflict with what a product team wants to build? The team interview panel is also where the mentorship dimension gets evaluated. The listing says you will mentor engineers in AI, native, and spec-driven development practices. The team wants evidence that you can teach, not just build. They will look for how you explain your reasoning, how you respond to questions you were not expecting, and whether you demonstrate genuine curiosity about other people's perspectives and expertise. Stage 6, which not every company does, but PE-backed companies often include, is a conversation with engineering leadership or a cross-functional leadership panel. This might include the VP of engineering, the chief technology officer, or even someone from K1's operations team. At this level, the conversation shifts from technical assessment to strategic alignment. Can you articulate how the AI Foundations team's work connects to employees' business outcomes? Do you understand the competitive landscape well enough to explain why AI differentiation matters for employees' market position? Can you demonstrate that you think about engineering as a value creation function, not just a cost center? If this sounds like a lot of stages, it is. Senior AI engineering interviews at PE-backed companies are thorough because the cost of a bad hire at this level is enormous, not just in salary, but in the architectural decisions that a senior engineer makes that persist long after they have left the company. Employee needs to be confident that the person they hire will make systems-level decisions that serve the platform well for years. Here is my overall assessment of how to navigate this pipeline successfully. Optimize for depth over breadth. Most candidates try to demonstrate that they know a little bit about everything in the job listing. The candidates who get offers demonstrate that they understand the deep architectural challenges of building reliable AI systems at scale, and that they have a clear, well-reasoned point of view on how to solve those challenges. The interview process is designed to surface depth of understanding, not breadth of keyword familiarity. We have mapped the pipeline. Now I need to take you inside the evaluation rubric, the actual dimensions that interviewers score on, and the specific failure modes that cause candidates to be eliminated at each stage. This is where preparation separates from guesswork, and I'm going to be as precise as possible about what you should expect and how to prepare. Let me start with a principle that governs the entire interview process for systems definition roles, which is fundamentally different from the principle that governs interview processes for feature delivery roles. In a feature delivery interview, the evaluators are asking, can this person build what we need? In a systems definition interview, the evaluators are asking, can this person decide what should be built? That distinction changes everything about how questions are framed, how answers are scored, and what constitutes a passing response. In a feature delivery interview, a strong answer demonstrates implementation skill. Here is how I would build this component. Here are the technologies I would use. Here is the code. In a systems definition interview, a strong answer demonstrates judgment. Here is why I would choose this approach over the alternatives. Here are the trade-offs I am explicitly accepting. Here is how this decision affects the rest of the system. And here is how I would know if this decision was wrong. With that principle in mind, let me walk through the specific question types you should prepare for. Category 1, architectural decomposition questions. These are the backbone of the technical interview for this role. The interviewer presents a high-level problem, something like, we need to build an evaluation framework that can benchmark the quality of AI-generated candidate matching across all 3 of our products, and asks you to decompose it into an architecture. The evaluation rubric for these questions typically scores on 4 dimensions. First, component identification. Did you identify the right set of components needed to solve the problem? Second, interface definition. Did you clearly define how those components communicate with each other, including data formats, API contracts, and error handling at boundaries? Third, trade-off articulation. When you made a design choice, did you explicitly name what you were trading off against and why? Fourth, failure mode awareness. Did you proactively identify how the system could fail and propose mitigation strategies? The most common failure mode for candidates on architectural decomposition questions is premature optimization. Candidates jump immediately to implementation details, which LLM model to use, which vector database to choose, what the embedding dimensions should be, without first establishing the system boundaries, the success criteria, and the constraints. The interviewers want to see that you work top-down. Start with the business requirement, define the system boundaries, establish the interfaces, and then make implementation choices within that framework. Let me give you a concrete example of how to structure a strong response. If asked to design an evaluation framework for AI-generated outputs, start by asking clarifying questions that demonstrate systems thinking. What types of outputs are we evaluating? What is the acceptable latency for evaluation to complete? Does the evaluation need to run synchronously within the generation pipeline, or can it be asynchronous? What governance requirements apply? Who consumes the evaluation results? Humans, automated systems, or both? Then decompose the problem into layers. The evaluation framework needs a data collection layer that captures AI inputs and outputs in a structured format. It needs a metric computation layer that calculates relevant quality metrics. It needs a drift detection layer that identifies when quality metrics deviate from established baselines. It needs a reporting layer that surfaces results to the right stakeholders. And it needs a governance integration layer that connects evaluation results to the Watson-X governance infrastructure. Each of those layers can then be discussed in terms of specific implementation choices, technologies, and trade-offs. But by establishing the architecture first, you demonstrate the exact capability this role requires. The ability to define systems, not just build them. Category 2, behavioral questions mapped to team values. The AI Foundations team operates with what the listing calls high ownership and high autonomy. The behavioral questions in the interview are designed to surface evidence of these qualities. Prepare specific examples from your experience that demonstrate 3 things. First, self-directed problem identification. Tell me about a time you identified a technical problem or architectural weakness before anyone asked you to look at it. What did you do? The strong answer shows that you proactively investigate, quantify the risk, and propose a solution, not that you waited for a ticket to appear in your backlog. Second, cross-team influence without authority. Tell me about a time you needed to get another team to adopt a technical standard or pattern that you defined. How did you approach it? The strong answer shows that you build alignment through clarity, documentation, and demonstrated value, not through escalation or organizational authority. Third, judgment under uncertainty. Tell me about a time you had to make an architectural decision with incomplete information. What was your framework for making the decision, and how did you evaluate afterward whether it was the right one? The strong answer shows that you have a structured decision-making process, that you're comfortable with ambiguity, and that you build in mechanisms to learn from your decisions over time. Category 3, governance and responsible AI questions. This is the category that most AI engineering candidates are least prepared for, and it is the one that can differentiate you most strongly at Employ. Expect questions that probe your understanding of AI bias in hiring contexts. For example, if our candidate matching system consistently ranks candidates from certain demographic groups lower, how would you detect that, and what would you do about it? The strong answer addresses detection through statistical analysis of matching outcomes across demographic groups, mitigation through model architecture choices and post-processing adjustments, and prevention through evaluation framework design that includes fairness metrics as a first-class concern. Expect questions about explainability. For example, if a customer asks why the AI screening companion recommended a particular candidate, what information would our system need to provide? And how would you architect the system to make that information available? The strong answer demonstrates understanding of feature attribution methods, logging strategies that capture the reasoning chain of an AI system, and user interface considerations for presenting AI explanations to non-technical users. Expect questions about governance integration. For example, how would you design an evaluation pipeline that integrates with an external governance platform like IBM watsonx? What data does the governance platform need? How frequently does it need updates? And how do you handle the case where the governance platform flags an issue with a production system? The strong answer shows that you think about governance not as an afterthought, but as an integral component of the system architecture, with its own data flows, its own latency requirements, and its own failure modes. Category 4, technical depth probes. These are not LEET code problems. They are focused technical conversations where the interviewer digs into your understanding of specific technologies and patterns relevant to the role. Expect depth probes on async Python. The listing specifically calls out asyncio, and the interview will likely include questions that test your understanding of Python's async concurrency model, event loops, task scheduling, and the practical patterns for managing concurrent LLM calls without blocking. Can you explain the difference between asyncio.gather and asyncio.create_task? Can you describe how you would implement a semaphore-based rate limiter for API calls in an async Python context? Can you explain when you would use asyncio versus multiprocessing for CPU-bound versus I/O-bound AI workloads? Expect depth probes on state management. The listing calls out experience persisting state across sessions and handling concurrency when multiple agents interact with shared data. The interview may present a scenario where two agents need to coordinate their actions on a shared data set and ask you to design the state management strategy. Can you articulate the trade-offs between optimistic and pessimistic concurrency control in an event-driven AI system? Can you describe how you would implement session state persistence for an agent that operates across multiple asynchronous invocations? Expect depth probes on schema enforcement. Given the emphasis on structured outputs using Pydantic, Zod, or JSON schema, the interview may ask you to design a validation pipeline for AI-generated outputs. Can you explain how you would handle the case where an LLM produces output that partially conforms to the schema? Some fields are correct, but others are malformed. Can you describe a retry strategy that maximizes the chance of getting conformant output without wasting tokens or latency? The meta skill across all 4 question categories is articulation under pressure. The interview evaluators are not just scoring whether your answers are technically correct. They are scoring whether you can explain complex ideas clearly, whether you acknowledge uncertainty honestly, and whether you demonstrate the communication capability that the role requires for cross-team influence and mentorship. My recommendation for preparation is this. For each of the technologies and patterns in the job listing, prepare not just to explain what they are, but to explain when you would use them versus alternatives, what trade-offs they involve, and how they interact with the other components of the system. The interview is not a knowledge test. It is a judgment test. And judgment is demonstrated through the quality of your reasoning, not the quantity of your keywords. There is a spectrum of candidates who will apply for this role, and the compensation they receive will vary by as much as $60,000 depending on where they fall on that spectrum. I want to map that spectrum for you precisely so you understand not just what skills are required, but which specific skills command the premium that pushes your total compensation toward the top of the band. Let me define 3 tiers. Tier 1 is what I call qualified but undifferentiated. These candidates meet the basic requirements of the listing. They have 4 or more years of experience building AI systems. They have worked with Python and LLMs. They have some exposure to RAG and vector databases. They have built things that shipped to a production. These candidates will likely receive a base salary offer in the $165,000 to $175,000 range, which is the bottom of the band for this role. Tier 2 is what I call competitive. These candidates do not just meet the requirements, they demonstrate depth. They have not just used LangChain, they have built custom orchestration layers that solve problems LangChain could not handle out of the box. They have not just worked with vector databases, they have evaluated multiple vector storage solutions and can articulate the trade-offs between them in specific contexts. They have not just built RAG pipelines, they have built RAG pipelines that operate at scale under governance constraints. These candidates will receive base salary offers in the $175,000 to $190,000 range. Tier 3 is what I call architecturally differentiated. These are the candidates who get the top of band offers, the ones where the total compensation package reaches or exceeds $230,000. These candidates do not just build systems, they define systems. They have experience setting architectural standards across multiple teams. They have experience integrating AI capabilities with governance frameworks. They have experience building infrastructure that other engineers build on top of. They can point to specific examples where their architectural decisions became the standard that an organization adopted. Now, let me tell you exactly which skills drive the movement from Tier 1 to Tier 3. The first differentiating skill is what I call governance-aware architecture. In 2026, the ability to build AI systems that are fast and accurate is table stakes. It is the minimum. What differentiates Tier 3 candidates is the ability to build AI systems that are fast, accurate, and governable. This means designing systems where every AI decision can be traced back to its inputs, where bias can be measured and monitored continuously, where the confidence level of AI outputs is quantified and communicated to downstream consumers, and where the entire system can produce an audit trail that satisfies regulatory requirements. The hiring landscape is shifting beneath the feet of most AI engineers, and many of them have not noticed yet. The regulatory environment for AI and hiring is intensifying rapidly. New York City's local law 144 already requires bias audits for automated employment decision tools. The EU's AI Act classifies AI systems used in employment decisions as high risk, subjecting them to stringent transparency and documentation requirements. For Employ, whose products are used by 23,000 companies to make millions of hiring decisions per year, governance is not a philosophical concern. It is a legal and business-critical requirement. If you can demonstrate in the interview that you understand this regulatory landscape and that you have experience building AI systems that are designed from the ground up for governance compliance, you immediately move from Tier 1 to Tier 2. And if you can further demonstrate that you have experience integrating AI systems with specific governance platforms and defining organizational standards for AI auditability, you move to Tier 3. The second differentiating skill is multi-system abstraction design. I discussed this in the technical architecture section, but let me now frame it specifically as a compensation differentiator. Most AI engineers build for a single product. The Tier 3 candidate for this role demonstrates the ability to build AI infrastructure that abstracts across multiple products with different data models, different API surfaces, and different customer expectations. This is a rare skill because it requires a specific kind of systems thinking that most engineers do not practice. It is not enough to be a good AI engineer. You need to be a good platform engineer who happens to specialize in AI. You need to think about your work not as building an AI system, but as building an AI platform that other engineers consume as a service. This means thinking deeply about API design, about backwards compatibility, about versioning strategies, about developer documentation, and about the developer experience of using the tools and frameworks you create. The third differentiating skill is evaluation framework design. The job listing mentions evaluation frameworks for benchmarking, regression testing, and drift detection. This is an area where most AI engineers have surface-level experience. They know that evaluation matters. They have used standard metrics like F1 score or BLEU score, and they have maybe built a simple test suite for a model. But Tier 3 candidates have designed comprehensive evaluation systems that capture multiple dimensions of AI output quality, that detect subtle performance degradation over time, and that integrate with CI/CD pipelines to prevent regressions from reaching production. In the context of Employ's AI Foundations team, evaluation is not an afterthought. It is a core product of the team. The evaluation frameworks you build are used by every product team to validate their AI features. If your evaluation framework misses a class of errors, those errors propagate across the entire platform. The ability to design robust, comprehensive evaluation systems is one of the highest leverage skills you can demonstrate. The fourth differentiating skill is async systems mastery at the Python level. The job listing's emphasis on asyncio and asynchronous workflows is not incidental. AI workloads that interact with external LLM APIs are inherently I/O bound, and the entire AI Foundation stack is built on async patterns. Tier 1 candidates know the basics of async/await syntax. Tier 2 candidates have built production systems using asyncio with proper error handling and resource management. Tier 3 candidates understand the internals of Python's event loop, have experience with advanced patterns like async generators, async context managers, and structured concurrency, and can design async systems that handle back pressure, rate limiting, and graceful degradation under load. The fifth differentiating skill is failure mode engineering. The job listing calls out retries, fallback strategies, and failure mode containment. In AI systems, failure is not an edge case. It is a regular occurrence. LLMs sometimes produce malformed output. API calls sometimes time out. Vector search results sometimes return irrelevant documents. The candidate who gets the top of band offer is the one who designs for failure as a first-class concern, not a catch block at the end of a try statement. Failure mode engineering means thinking systematically about every way each component can fail, designing specific handling strategies for each failure mode, implementing circuit breakers that prevent cascading failures, building fallback pathways that degrade gracefully instead of failing catastrophically, and instrumenting the entire system with telemetry that makes failures visible and diagnosable. Here is a concrete example that ties several of these skills together. Imagine you are building the orchestration layer for an AI agent that generates personalized rejection feedback for candidates. The agent needs to retrieve the candidate's application data, compare it against the job requirements, generate a nuanced and empathetic feedback message, validate that the message conforms to the customer's communication guidelines, check the output for potential bias through the governance layer, and deliver the message to the candidate. A Tier 1 candidate would build this as a sequential pipeline: retrieve data, generate message, validate, deliver. A Tier 2 candidate would build it as an async pipeline with retry logic and structured output validation. A Tier 3 candidate would build it as a governance-integrated, event-driven system with circuit breakers at each external dependency, fallback strategies for each failure mode, structured telemetry for monitoring, a schema-enforced output contract, and integration with the evaluation framework for continuous quality monitoring. The difference between those three approaches is the difference between a $165,000 base salary and a $195,000 base salary. The Tier 3 approach is what the AI Foundations team needs, and it is what the interview is designed to identify. Let me also mention a set of adjacent skills that are not listed in the job posting, but that create unexpected competitive advantage. The first is experience with multi-tenant SaaS architecture. Employees' products serve 23,000 customers, each with their own data, their own configurations, and their own expectations. The AI layer needs to be multi-tenant aware, meaning it needs to isolate customer data, respect customer-specific configurations, and scale across a wide range of usage patterns. If you have experience building multi-tenant AI systems, that is a significant advantage. The second adjacent skill is experience with cost optimization for AI workloads. LLM API calls are expensive. Vector database operations at scale consume significant compute resources. A senior AI engineer who can design systems that minimize token usage, optimize batch processing, and intelligently route between expensive high-capability models and cheaper lightweight models for different tasks will be highly valued at a PE-backed company where cost efficiency directly affects profitability. The third adjacent skill is experience with data pipeline design for AI training and evaluation. The AI Foundations team needs high-quality data to train models, fine-tune prompts, and evaluate system performance. If you have experience designing data pipelines that clean, transform, and prepare training data from production systems, that is a skill that bridges the gap between data engineering and AI engineering in a way that this team specifically needs. One of the most strategically undervalued aspects of this role is what it sets up for your career over the next decade. Most candidates, when evaluating a job opportunity, focus almost exclusively on the immediate compensation and the immediate work. But the long-term career trajectory from a systems definition AI engineering role at a PE-backed talent acquisition company creates a set of options that are rare and valuable in the current market. Let me map the trajectory across 3 time horizons: 3 years, 5 years, and 10 years. In the 3-year horizon, assuming you join the AI Foundations team now and perform at the level the role demands, several things happen simultaneously. First, you accumulate deep expertise in a domain, talent acquisition AI, that is experiencing explosive growth. The global ATS market was valued at $3.28 billion in 2025 and is growing at 8.2% compound annual growth rate through 2030. AI capabilities are the primary driver of that growth. Every major ATS vendor, Greenhouse, ICIMs, Smart Recruiters, Workday, is investing heavily in AI, and the engineers who build these systems are a scarce and specialized talent pool. Second, in 3 years, you have likely progressed from senior AI engineer to either a staff engineer title or a technical leadership position within the AI Foundations team. At PE-backed companies, career progression can be faster than at large public companies because the team sizes are smaller, the scope of impact per person is larger, and there is less bureaucratic overhead in the promotion process. A strong performer in this role could be leading the AI Foundations team within 2 to 3 years. Third, and this is the K1 trajectory play I mentioned earlier, the 3-year mark is roughly when K1's exit window for employee opens. If the exit happens, whether through a strategic acquisition by a larger HR tech company, a sale to another PE firm, or a less common path like an IPO, your vested equity converts to liquid value. This is the moment when the total compensation picture becomes dramatically more interesting than the base salary alone. In the 5-year horizon, you are looking at multiple career pathways depending on which direction you want to take. Pathway 1 is the deep technical track. If you stay in individual contributor engineering, 5 years of systems definition AI experience at scale positions you for staff or principal engineer roles at companies that are building AI platforms. The experience of designing AI infrastructure that works across multiple products, under governance constraints, at the scale of millions of interactions, is directly transferable to companies like Salesforce, Workday, ServiceNow, or any other enterprise SaaS platform that is building AI capabilities. Staff engineer roles at these companies command total compensation in the $300,000 to $500,000 range. Pathway 2 is the engineering leadership track. If you move toward management, 5 years of experience leading the AI Foundations team at Employ positions you for VP of Engineering or Head of AI roles at mid-sized technology companies. The unique value you bring is not just AI expertise. It is the experience of building and scaling AI teams in a complex organizational environment with governance requirements. Companies building AI products in regulated industries, healthcare, finance, insurance, education, pay a premium for engineering leaders who understand how to build AI systems that are both powerful and compliant. Pathway 3 is the startup founder track. After 5 years of deep immersion in how talent acquisition works, what AI capabilities recruiters and hiring managers actually need, and what the gaps are in the current product landscape, you are in an extraordinarily strong position to found an AI native talent acquisition startup. The domain knowledge you accumulate at Employ, understanding the specific data models, workflows, pain points, and regulatory constraints of the hiring industry, is a competitive moat that pure AI engineers without domain experience cannot replicate. In the 10-year horizon, the trajectory depends on which pathway you chose at the 5-year mark, but all pathways converge on the same fundamental career asset. You are one of a relatively small number of engineers in the world who built the first generation of production-grade AI systems for talent acquisition at scale. That is a permanent credential. As AI becomes increasingly central to how companies hire, and every market indicator suggests this is an irreversible trend, the engineers who built the foundational systems during this period will be recognized as domain pioneers. Let me also address the network effects of this role, because they are significant and often overlooked. The AI Foundations team at Employ sits at the intersection of several high-value professional networks. First, the K1 portfolio network. K1 has invested in over 275 companies. Being part of a K1 portfolio company gives you access to events, knowledge-sharing sessions, and informal connections across that entire portfolio. This includes companies in cybersecurity, legal tech, governance software, and other enterprise verticals where AI engineering talent is in high demand. Second, the IBM watsonx Partnership Network. Working with IBM watsonx governance means interacting with IBM's enterprise AI ecosystem, which includes access to IBM's technical community, events, and partnership resources. This connection is particularly valuable if your long-term career interest is in AI governance, responsible AI, or enterprise AI strategy. Third, the talent acquisition industry network. By building AI systems for an ATS company, you will interact with recruiters, HR leaders, and talent acquisition professionals across thousands of organizations. These relationships are valuable not just for your own career mobility. Knowing the people who control hiring at thousands of companies is a structural career advantage, but also for any future entrepreneurial ventures in the HR tech space. The compensation progression over these time horizons is also worth mapping. Starting at $230,000 total compensation in year 1, a strong performer can expect total compensation to grow to approximately $270,000 to $300,000 by year 3, accounting for salary increases and growing equity value. At year 5, depending on the pathway chosen, total compensation could range from $350,000 at a senior IC role at a larger company to $500,000 or more at a leadership level. At year 10, the range widens dramatically based on your choices, but the floor for an engineer with this background and trajectory is comfortably in the $300,000 range, with the ceiling being essentially limitless if you have founded or are leading a successful venture. To properly evaluate whether the senior AI engineer role at Employ is the right move for you, you need to understand the competitive landscape, both the companies competing with Employ for customers and the companies competing with Employ for your talent. These two competitive dynamics interact in ways that directly affect your compensation, your career trajectory, and the strategic significance of the work you would be doing. Let me start with the ATS competitive landscape, because the shifts that happened in 2025 fundamentally reshaped this market. 3 major acquisitions occurred that every serious candidate for this role should know about. SAP acquired Smart Recruiters, Workday acquired Paradox, a conversational AI platform for high-volume hiring, and ICIMS acquired Apply, expanding their multilingual screening capabilities across Latin America. These 3 deals share a common signal. Standalone ATS vendors are being absorbed into larger enterprise software ecosystems, and AI capability is the primary driver of that consolidation. This competitive dynamic matters enormously for Employ's position and for the strategic importance of the AI Foundations team. Here is why. Employ is not a standalone ATS. It is a portfolio of 3 ATS products under a PE umbrella. Its competitive strategy is different from any of its individual competitors because it can offer customers choice across market segments: JazzHR for small businesses, Lever for mid-market growth companies, and Jobvite for enterprise, while building shared AI capabilities across all 3. No other company in the ATS space has this portfolio breadth combined with a dedicated AI infrastructure team, but the competitive threat is real. Greenhouse, which is the dominant premium ATS for structured hiring, has been aggressively building AI sourcing and candidate matching capabilities. Their AI tools surface qualified candidates from their network and rank existing applicants with explainable scoring. ICIMS, with its enterprise-grade infrastructure and its new API integration, is pushing AI-driven screening and multilingual capability at a scale that specifically targets the large enterprise segment where Jobvite competes. And Workday, with its acquisition of Paradox, has added conversational AI automation directly into the most widely deployed enterprise HCM platform in the world. For the AI Foundations team at Employ, these competitive moves create both urgency and opportunity. The urgency is that if Employ's AI capabilities are not competitive with what Greenhouse, ICIMS, and Workday are offering, customers will migrate, especially in the enterprise segment where switching costs are high, but the potential ROI of better AI-driven hiring is significant enough to justify them. The opportunity is that Employ's multi-product architecture creates a unique AI advantage. By building a shared AI foundation that serves all three products, the team can deliver capabilities more efficiently than competitors who are building AI for a single product, and can create cross-product intelligence that no single product competitor can match. Imagine, for example, an AI system that learns patterns from millions of successful hires across JazzHR's small business customers, Lever's mid-market customers, and Jobvite's enterprise customers, and uses those cross-segment insights to improve matching and screening across all three platforms. No competitor with a single ATS product can access that breadth of data. This cross-product intelligence opportunity is one of the strongest strategic arguments for the AI Foundations team's existence, and it is something you should be prepared to discuss in the interview. Now let me map the competitive landscape for talent. Who else is trying to hire the person who fills this role, and how their offers compare? The most direct talent competitors are other HR tech companies with AI teams. Greenhouse's engineering team is based primarily in New York and San Francisco, and they are actively hiring AI engineers for their candidate matching and analytics capabilities. ICIMS, headquartered in New Jersey, has been building out their AI team aggressively following the Apply acquisition. Workday, with its massive engineering organization, competes for AI talent at a scale that smaller companies cannot match. Their total compensation packages for senior AI engineers regularly exceed $300,000. Beyond HR tech, the broader talent competition comes from every company that is hiring senior AI engineers, which in 2026 is essentially every technology company in existence. The market data is stark. 76% of employers cannot fill AI roles, according to Skillsoft's 2025 Workforce Intelligence Report. The average time to fill a senior AI engineering position at companies offering below a $200,000 base salary floor is 114 days, more than double the broader tech market average. Companies are competing fiercely for a finite pool of candidates who have the specific combination of AI expertise, systems design capability, and production engineering experience that this role requires. Employees' compensation offer, while competitive, does not match what a FANG company would offer in raw total compensation terms. A senior AI engineer at Google might receive $500,000 or more in annual total compensation. At Meta, similar numbers. At OpenAI or Anthropic, the equity upside can push total compensation into the seven-figure range for senior engineers who joined at the right time. But this comparison, while factually accurate, misses the strategic calculus. The question is not which company pays the most. The question is which role gives you the best risk-adjusted return on your next 3 to 5 years of career capital. At Google, you are one of thousands of AI engineers contributing to products that already have massive scale. Your individual impact, while not trivial, is diversified across an enormous organization. At Employ, you are one of a small team of engineers who are defining the entire AI architecture for a platform ecosystem serving 23,000 customers. Your individual impact is disproportionately large. Your architectural decisions become the standard. Your name is attached to the foundational systems. This impact asymmetry is the real differentiator, and it is what sophisticated candidates evaluate when choosing between a higher-paying role at a large company and a higher-impact role at a growing company. Market trends also favor Employ's position. The AI hiring technology market is expected to grow significantly through 2030, driven by regulatory pressure for more transparent and auditable hiring processes, increasing automation of high-volume recruiting workflows, and the growing sophistication of AI-powered candidate matching and assessment tools. Companies that establish strong AI capabilities in this period will have structural advantages that are difficult for later entrants to overcome. The AI Foundations team at Employ is positioned at the leading edge of this trend. For candidates evaluating this role, I would recommend explicitly comparing 3 dimensions: compensation, impact, and trajectory. On compensation, employee is competitive but not market leading. On impact, employee offers disproportionate individual impact relative to team size. On trajectory, employee offers a rare combination of AI systems experience, domain expertise accumulation, and PE equity upside that creates multiple high-value career pathways. The candidate who weighs all three dimensions, rather than optimizing solely for compensation, will make the better long-term career decision. We have analyzed the company, the architecture, the interview process, the skill requirements, the career trajectory, and the competitive landscape. Now I am going to give you the actionable strategy for putting together the strongest possible application for this role. Let me start with resume optimization, because the resume is the first and most important filter. For this specific role at this specific company, your resume needs to communicate three things above all else, and it needs to communicate them within the first 10 seconds of a recruiter or an AI screening system scanning the document. The first thing your resume must communicate is systems-level AI experience, not feature-level AI experience. Most AI engineering resumes describe the features they built. I implemented a chatbot, I built a recommendation system, I deployed a RAG pipeline. For this role, you need to reframe your experience in terms of systems and infrastructure. Instead of built a RAG pipeline for customer support, Wright designed and deployed the RAG infrastructure that served as the foundation for all AI-powered customer interactions across three product lines. Instead of implemented LLM-based candidate matching, Wright architected the evaluation and schema enforcement framework governing all LLM-generated outputs in production. The language shift is subtle but critical. The AI Foundations team is hiring someone to define systems, not to build features. Your resume needs to reflect that distinction in every bullet point. The second thing your resume must communicate is governance awareness. Include any experience you have with responsible AI practices, bias detection, explainability, audit trails, or compliance with AI regulations. If you have worked in a regulated industry, healthcare, finance, insurance, government, emphasize the compliance dimension of your AI work. If you have specifically integrated with governance platforms or built monitoring systems for AI output quality, those experiences should be prominently placed on your resume. The third thing your resume must communicate is cross-team influence. The listing emphasizes establishing architectural patterns adopted across teams and mentoring engineers. Your resume should include specific examples of technical standards you defined that other teams adopted, documentation you created that became the reference for AI development practices, or mentoring relationships that resulted in measurable growth for junior engineers. On format, keep it clean, single column, and optimized for automated parsing. No multi-column layouts, no graphical skill bars, no embedded images. Use standard section headers that ATS systems recognize: experience, skills, education. For the skills section, list the specific technologies from the job posting: Python, Asyncio, LangChain, LangGraph, Pydantic, Pinecone, pgvector, Weaviate, Kafka, Docker, Kubernetes, but only the ones you have genuine experience with. Do not keyword stuff. The AI screening companion evaluates context, not just keyword presence. Now let me talk about portfolio and project preparation. For a systems definition role, the most compelling portfolio piece is not a polished demo, it is a well-documented architecture. If you have an open source project or a technical blog post that describes the architecture of an AI system you built, including the trade-offs you made and the failure modes you considered, that is worth more than a working demo of a flashy AI feature. Consider creating a case study document, a 2 to 3 page write-up of the most complex AI system you have designed that you can share during the interview process. The case study should cover the problem statement, the architectural approach, the specific trade-offs you made, how you evaluated the system's performance, and what you would do differently with the benefit of hindsight. This kind of artifact demonstrates exactly the skills the AI Foundations team values: systems thinking, trade-off awareness, and self-reflective engineering judgment. For the technical preparation itself, here is my specific recommendation. Spend 70% of your preparation time on system design practice. Take the components mentioned in the job listing: agents, RAG pipelines, orchestration layers, evaluation frameworks, and practice designing complete systems that incorporate them. For each design, practice articulating the component boundaries, the data flow between components, the failure modes at each boundary, and the governance integration points. Spend 20% of your preparation time on deepening your expertise in the specific technologies listed. Focus especially on async Python patterns, Pydantic schema enforcement, and at least one vector database deeply enough that you can discuss its performance characteristics, scaling limitations, and operational requirements in detail. Spend the remaining 10% on understanding employees' business context, read about the ATS market, understand who the competitors are, research the IBM WatsonX partnership, and be prepared to articulate how the AI Foundations team's work connects to employees' competitive positioning. On timing and networking. PE-backed companies often have smaller, more personal hiring pipelines than large public companies. If you can find a connection to anyone at Employ, Jobvite, Lever, or JazzHR through your professional network, a warm introduction to the hiring team is significantly more valuable than a cold application through the ATS. LinkedIn is your best tool here. Search for engineers with AI in their titles who work at Employ and reach out with a personalized message that demonstrates you have done your homework on the company and the role. If you are applying cold, the best timing for your application is within the first 2 weeks of the listing being posted. After that, the recruiter has already built a pipeline of candidates, and the late applications face diminishing returns on attention. Submit early, submit strong, and follow up professionally if you have not heard back within 2 weeks. On the cover letter, yes, I recommend writing one for this role, even though many candidates skip them. The cover letter for a systems definition role should not rehash your resume. It should be a one-page articulation of your engineering philosophy, how you think about building AI systems that other engineers can build on top of, how you balance technical ambition with governance responsibility, and why the specific challenge of building AI infrastructure across multiple product platforms is a problem that genuinely excites you. The hiring manager for the AI Foundations team is looking for someone who understands that this is not a coding job. It is a judgment job. Every element of your application should reinforce that you possess the architectural judgment that the role demands. We have covered an enormous amount of ground in this lecture. Let me now synthesize everything into a unified framework that you can carry into your preparation in your interview. The core thesis of this lecture is this. The senior AI engineer role on Employ's AI Foundations team is not an AI feature engineering job with a fancy title. It is a systems architecture role that happens to focus on AI infrastructure. The gap between how most applicants will interpret this listing and what the role actually requires is where the competitive advantage lives. Candidates who prepare for a feature delivery interview will fail. Candidates who prepare for a systems definition interview will succeed. Let me give you the consolidated framework in 5 principles. Principle 1, think in systems, not in features. Every answer you give in the interview, every bullet point on your resume, and every example in your cover letter should demonstrate that you think at the systems level. You do not build features. You build the infrastructure that makes features possible. You do not write code. You define contracts. You do not solve problems. You design frameworks for solving classes of problems. Principle 2, governance is not optional. It is architectural. The IBM Watson-X partnership, the AI screening companion's bias monitoring, the audit trail requirements, these are not compliance checkboxes to be handled by a separate team. They are core architectural requirements that must be designed into the system from the beginning. Every design decision you make should account for explainability, auditability, and fairness. In the interview, proactively raise governance considerations even when the question does not explicitly ask about them. Principle 3, reliability is the product. The job listing says you will transform probabilistic model outputs into reliable production-grade product capabilities. That transformation, from probabilistic to reliable, is the core value proposition of the AI Foundations team. Your schema enforcement layer, your retry strategies, your fallback pathways, your evaluation frameworks, these are not implementation details, they are the product. The AI Foundations team does not ship AI capabilities, it ships AI reliability. Principle 4, the multi-product context changes everything. Employ is not a single product company. The AI Foundations team serves 3 products with different architectures, different data models, and different customer bases. Every design decision must account for this heterogeneity. Candidates who design for a single product will give answers that are technically correct, but contextually wrong. Candidates who design for a multi-product platform will give answers that demonstrate the specific judgment this role requires. Principle 5, impact compounds over time. This role is not a destination, it is a launchpad. The domain expertise you accumulate, the architectural decisions you make, the governance frameworks you implement, and the professional network you build all compound over a 3 to 10-year horizon. The candidates who evaluate this role purely on year 1 compensation will undervalue it. The candidates who evaluate it on the full trajectory will see one of the highest leverage career opportunities in the AI engineering market. Now let me prepare you for the eSync certification assessment that accompanies this lecture. The assessment is designed to validate that you have internalized the key insights and frameworks from this lecture and that you can apply them in a practical context. It is not a knowledge test, it is an application test. The assessment will evaluate your understanding across 4 dimensions. First, your ability to identify the hidden evaluation criteria for this role and articulate why they matter. Second, your ability to design AI system architectures that account for the multi-product, governance-constrained environment described in this lecture. Third, your understanding of the compensation structure and career trajectory for this type of role. Fourth, your ability to construct an application strategy that differentiates you from other candidates. Upon passing the assessment, you will receive an eSync Technologies Certificate of Completion that validates your preparation for the Senior AI Engineer role at Employ Inc. This certificate represents a structured, research-backed analysis of the role that goes significantly beyond what any standard job listing or career guide provides. Let me close with a forward look. The next lecture in the eSync Career Intelligence series covers a role that sits at the opposite end of the AI infrastructure spectrum, a role where the technical challenge is not building reliability into AI systems, but building intelligence into systems that have never had AI at all. The company is one you use every day, and what they evaluate in their interview process is even more surprising than what we covered today. Thank you for your time and your attention. The gap between where most applicants are and where this role requires you to be is exactly what this lecture was designed to close. The knowledge you now have about Employ's hidden operating system, about the technical architecture beneath the job listing, about the evaluation dimensions that do not appear in any posting, and about the specific skills that command premium compensation, this knowledge is the product. This knowledge is your competitive advantage. Go build something remarkable.